Okay. صباح الخير أعزائي الطلبة. This is the إن شاء الله today I'll try to finish chapter 1 and in which I would like to start with the video that shows the a failure in a protection system. What would what would be the consequence of having such conditions? This is transformer faults, which is not detected by protection system, and this is the consequence. See, enjoy the video. I'll just show you, play it now. This is just imagine this flow like a bomb, okay, uh, which is won't just damage the transformer in which the fault happens. It might damage the nearby equipments. And as you can see, this fire that's initiated by a fault, a current is too high that not only ignite a fire, but also will melt even the conductors. It's so high that has high thermal energy that can melt also metals. Okay, and that's why we can use high current for welding, we can use it for, let's say, aluminum smelters, and so forth. Today, the plan to discuss the other part of this lecture. Before I get to the other part, I have mentioned we have different way to detect faults, right, Shabab? Can you mention to me one criteria based on which we can detect a fault? ممكن أحد؟
voltage transformer.
لا أعطوني criteria. يعني voltage transformer هو it's an input information so that the relay knows there is a fault or not a fault. But how do I know based on the current and voltage frequency that there is a fault?
Shunt fault and open phase.
These are type of faults. How do I know that we have an open phase, or how do I know there is a short circuit? How do you know there is an overload? Based on what I take a decisions?
Over current.
Based on currents, currents measurements. If there is an overcurrent over higher than the full load current or normal current, then this is one criteria of detecting faults. Second,
over voltage بعد بيكون بعد.
could be over voltage or under voltage conditions. Third,
الفريكونسي بعد بيكون
based on under frequency over frequency conditions. Fourth, difference in currents. Okay, it's not necessarily magnitude of currents. Sometimes you take a difference in currents, like differential protections. Fifth, yes. Sometimes we take voltage over frequency conditions. Volt over here. يعني sometimes we take the power, reverse in power, okay, which is directional relays. Sometimes we take the impedance measurements, like in distance relays, based on which we know there is a fault in the transmission line or not. So there are different criteria. Some we have non-electrical criteria, like we measure the temperature, based on which I know a winding of a generator or a winding of transformer is overheated due to overcurrent or due to other, maybe the ambient temperature is too high. It's not as specified as per the manufacturer of the equipment. Anyhow, today I'll show you just those functions by giving you a practical. This is an example of a transformer protection relay from Sviger Engineering Laboratory. Was one of the famous relay manufacturing company in USA. This relay, okay, and it has several protection functions in them. And the inputs, so where is the power transformer we are talking that we are protecting is this. This is the power transformer, and it is grounded through, this could be a delta side, this is the Y side, that's why the Y side is grounded through, grounded to the ground, the neutral points grounded. And so this relay needs an inputs, right? As we mentioned, we need, so from this is a VT from which the voltage at this terminal at the delta side is can be measured or can be. So I have three. What does three means here? I have this single line diagram means this VT is connected probably as star star from which this is a three conductors going to the relay. Okay. So plus of course the neutral points. Now this is also a CT, current transformer, which provide what will be the current flowing at the delta side transformer. So I need 3 CTs, okay, in this case as input, one for each phase, okay. At the star side, I have also a transformer, a CT here, which provide also 3 CTs, one for each phase given to this relay. In addition, I have a CT for the neutral, and we call it the neutral CT. And this is, as you can see, just single CT. So all of this are inputs to the relay so that a relay can take a correct decision. It can identify whether this is a normal condition or abnormal conditions. Now, what are these protection functions that are provided? Inshallah, we'll elaborate on them in the coming chapters. One of them is as I mentioned, because I have input voltage, I can know, is this voltage an over voltage condition, which is the 59 function, a protection function, or it is under voltage conditions, which is the 27 function. So these numbers represent the protection functions according to the IEEE standards, where they have specified a number for each protection functions. So when I say 59 means an over voltage, 27 means under voltage. But sometimes they add to that letter number as a letter P and Q. So P means for phase, Q means for negative sequence. So of the voltage quantity, you determine the negative sequence of that voltage, and based on the negative sequence, you decide, is this an overvoltage condition or not? Then this is a negative sequence base, we call it 59Q. No, if you use the actual voltage, we call it the over 59P. And this is an overvoltage based on the actual phase voltages quantities. Now we have other like power. So from the current, from the voltages, I can also check, but not from voltage, I can determine the power direction, or I need to know also a current. So from this current, okay, so from the current and the voltage that is refused, okay, I can determine the power direction. Okay, so there is other function that is also based on voltage, which is the V over H, V over F, voltage over frequency function. This is 24. This is the normally at rated voltage and rated frequency, the ratio is known. Now, if you have low frequency, but at rated voltage, there will be an overfluxing in the core. Or if you are higher voltage, but at standard frequency at the 50 hertz, for example, you have also an overexcitation, overfluxing, we call it. And that leads to a core saturation. And we can detect this by this function, 24 function. We have frequency over or under, which is 81. 81O means over frequency, or 81U, it is under frequency. So how do we detect the frequency? We measure it from the voltage. Voltage, we detect its frequency of the voltage, and based on which relay knows, is this an over frequency or under. From the voltage here, I can detect loss of potential. Yani, is the breaker is open at this side? Is there any supply coming to the transformer? If there is no voltage, it is a loss of potential condition, we call it. So all of these require voltage as input, okay? Now, what functions that require currents only as to take decisions, like the 50 functions. 50 is the overcurrent. We have two types of overcurrents. The one that takes instantaneous action, fast action, we call it the 50 function, overcurrent functions. There is also this functions classified as 50B or 50G or 50Q. Okay, so it depends. Did I use the phase current to detect and then overcurrent, or did I use the negative sequence current to detect there is an overcurrent conditions, or did I use the ground currents to detect that there is an overcurrent conditions? We have the 51, it is time delayed overcurrent prediction, where the relay does not decide, the operating time of the relay is a function, is inversely proportional to the currents. So it is like, this is the trip time versus the current. The higher the current, the faster the operating time. Okay, so this is the 51 protection function. We call it time over current protection. So these two, based on require an overcurrent, require an current as input. This one also, which requires now the current in the neutral. Okay, now it is same function as 50 and 51, still instantaneous, but based on the neutral current. Now, this is normally provide protection against air faults, ground faults. So when you have normally ground faults, you will have a current in the neutral, okay, conductor, in the ground conductor. This is, and as a result, you can detect ground force by measuring the neutral conductor currents, or the ground conductor current. We can similarly at the star side of the power transformer, I have also CTs in each phase. So we have 50 and 51 functions, which is the overcurrent instantaneous function and the time overcurrent functions. But also we see that this function, we call it current differential, where it takes the current from the delta side or the HV side, if this is an HV side, and this is the LV side, for example. So it takes the current from from each phase of the HV side and compare it with the currents from each phase of the LV side. And now, based on this, it decides, is there a fault inside the transformer or not? So this is called current differential based on current difference, okay? There are other also functions that is non-electrical that's provided by this relay. Like we use inputs not from CT or VT, the inputs from RTD. have سمعتون عن RTD؟ So RTD means resistance or resistor, okay, temperature device. Okay, so what does this? It's a resistance that its value varies with the temperature. Okay, and normally this is inserted in the transformer winding so that I know what's the current temperature, what's the actual temperature of this winding. So instead of measuring the current to know the heating effects of that current on the winding of the transformer, no, here we directly measure the temperature of the winding. Or if it's a motor or a generator, I can have insert this detector on the winding of the generator stator or motor stator windings. Sometimes this is also inserted in the bearing of the generator, of bearing of the motor, so that I detect the temperature of the bearings. I can have it on the outdoor sensors so that I know the ambient temperature. Is it higher than specified or not? So these are temperature inputs to the relay, and based on which I can give alarms, okay? Or sometimes it is used in the trip actions. So this is the 49 functions. As you can see, you have so many protection functions that are in a relay so that we can detect any faults that can occur or an abnormal condition that can occur in a protected equipment. Here in this case is a transformer. Do you have any questions so far? So is it clear? What do you mean a protection relay? What are the protection functions? Why you need an input CT and VT? Okay, and where is the breaker is here? This is the circuit breaker. Now, if a relay find, based on these, any of those functions find faulty conditions, it will provide a trip command to circuit breaker to open, so it will disconnect the feeder. Okay, disconnect normally the supply to this transformer will be from this side. So it will disconnect, and this is the supply. But sometimes we might have two breakers at the two side of the transformer, so we disconnect the transformer from the two side. If it is a parallel transformer, we have. For radial systems, okay, So most probably this is the HV side and this is the LV side. Okay. Now what I'm planning to cover also today is now we see a protection functions here. What are the characteristics of a good protection functions? Okay. So what are the requirements to have a good protection system? And what are the inputs, relay inputs? As you say, you have seen already, inputs is a voltage, current, and sometimes could be a temperature. Sometimes we might have a GPS antenna signal, okay, for as input to a relay. We'll come to this, inshallah. The protection zones uh, and primary and backup protection. What do you mean by this? Directional relays and evolution of how the relays has developed from electromechanical to nowadays numerical relays. Now, what are the protection requirements? Now, to have a protection relay is considered good if it is sensitive. So sensitivity is one of the a good quality of a good protection system, and it is able to detect. So what does that mean? It's be able to detect faulted or abnormal conditions with minimum quantity of current or voltage or frequency. So this is the sensitivity. Now, I can say an example. Suppose you have a fuse, okay? And a fuse in our plugs is 13 ampere. And to check its sensitivity, what's the minimum current required for this fuse to blow, to open? And this is degree of sensitivity. So if it's operate at 13.01, means very sensitive. If it's operate at let's say 20% higher or 30% higher, is less sensitive. Okay, Shabab? Now, what do you expect 13 ampere? What is the current at which this fuse blow? أبو 13 أمبير الموجود في البلاجز. أنا
أتوقع
ريسبون
بيكون
كم بيكون؟
12 or 0.8 like that.
12 أمبير يفصل
0.9
فيه؟ ها؟
0.9
0.9؟
بيكون ببدي انه يصير اوبن.
لا. الفيوزز يعني some fuses takes 130% higher than this rated value for the fuse to blow within 1 hour. Okay, sometimes some fuses take 125%, some fuses take even higher. Okay, so this it's not like as sensitive as protective relays. Okay, in detecting faults or overcurrent conditions. Okay, Shabab? So this is an example of an sensitivity. We want a protection system that is very sensitive, okay, to detect the fault or abnormal conditions. Now, the second quality that we are looking for is the selectivity. And we mean selectivity is its ability to not just detect the fault with the minimum quantity of current voltages or the or frequency, but also to be able to uh, select the faulty equivalent and disconnect it from the system. So its ability to identify a problem that has happened, this is related to its sensitivity, and only react if there is a problem. So, and only the faulty equipment is uh, removed from the system. So when you have a protection system that the fault is not in the transformer that we are talking about, for example, this transformer and another transformer, when this relay trips this transformer while the force is not this transformer and other equipment, this means not selective. Okay, selective means its ability of protection function to identify the problem or the faulty conditions and acted correctly, okay, to remove the faulty equipment only from the system. So this is called selectivity. And that is linked to something called reliability. We want a protection system that is reliable. If you install it in the system for tens of years, it will always act correctly. Okay, so suppose I have a protection system that is there in the that has working in service for 100 years. Over 100 years, I had, for example, 100 faults. So for this 100 faults, for all these 100 faults is acted correctly. Means acted correctly means it in situation where it should not operate, it did not operate it, and in situation where it's supposed to operate and disconnect the equipment, it has operated correctly. So we have two aspects to means here is related to correct operations. Okay, so if we divide the number of incorrect operations or correct operation over all fault conditions, this is relate to us the reliability. So the reliability of the system, what do you think the reliability of a protection system? What's the percentage? Is it 90%, 80%, 88%? What do you think, Shabab? Reliability of a
It should be above 90.
above 90. It is 99.99. Okay, it's very reliable because you want to detect always the force that is a damaging force, and we want to make it as high reliability as possible. So how do we make it higher reliability? By having those functions. Several functions are there, so you can always detect any fault that can occur. Okay, so this is one thing that can improve the reliability of the protection function. So the reliability can be divided into two sections. Something called dependability, okay, and something called security. Now, we want to have the protection system to be dependable, means it always act correctly. It is the degree of it's the degree of certainty that relay will act correctly when it's supposed to act correctly. Okay, so always act correctly for faults within its protection zone. each protection function has a dedicated zones or equipment that has to protect. Okay, so if it can detect any fault that within that equipment and act correctly to clear that fault, this call, it makes the relay or the protection function dependable, which makes it reliable. Okay, but it can act incorrectly for fault outside. Okay, so security is related to it should not act incorrectly for fault external to the protected zone. So security is not just it should act always correctly for fault within the transformer if we are protecting a transformer. It should not also operate when a fault outside the transformer. It should not operate and it's supposed not operate and it did not operate. I mean, means make it secure. Okay. So that's why it's something now, reliability is measured based on the how many maloperations, yani, how many incorrect operations, whether a fault internal or external, that the relay failed either to detect or it detected something and it tripped incorrectly. Okay, so that is related to reliability. And a fourth quality, we want to have speed. We want to design a protection system that detects a faults, very sensitive detects a faults or abnormal conditions. It can select only the fault equipment and clear it from the system, which is selectivity. It is reliable. It's always take the correct actions, okay? But also as fast as possible. Okay, so speed is very important. Speed can reduce the damage. Okay. There is another, sometimes we add also, sometimes it has to be economical. I can have a protection functions for, why don't we have such functions to protect our TV, for example, or protect our motor at home? Why don't we use all of this function, Shabab? If it is good, if it can make system reliable, why don't we use them at home?
They are expensive.
Yeah, the cost. So the cost should justify. Now, as engineering, we want to do something good, but at a proportional cost. Okay, so here it should be economical. So I should always choose the protection function just good enough to provide the protection function required for that equipment at a reasonable price. Okay. Now, if your equipment costs $1, do you want to spend 100 dinar for the protection system? No. Right? If it's $1 cost, I will have a fuse of 50 fils or 25 fils to protect it. All right, Shabab? Now, why speed is an important, damage is proportional to the time. Damage in the equipment or in the conductors okay, is proportional to time. So we imagine that I square T times R, the thermal energy is proportional to this. The higher the current, this is the thermal, it's times also R, but I didn't right, R, okay, resistance of the conductors. So this is the thermal energy generated from the force. So either as I goes high, that's high damage, higher, of course, current higher than the full load current or the rated current of the equipment. I will have higher damage if I don't trip quickly. Also, we wait longer time. The longer time, the long heat generated, the higher the heat generated, that thermal heat, and that also create higher damage. Okay, so we want to take fast action so that the thermal let-through energy is reduced, and thus we reduce the damage. So what is the impact of fast response? Okay, fast response will reduce the let-through energy, as I mentioned to you, and so will reduce the damage. Less disruptions of loads, fast action. Sometimes you wait longer. Is not only one equipment get damaged, other also equipment get damaged. So you will reduce the number of loads that will be damaged from the faults. As you see, if the protection even fails, this is the worst case scenario. Then, and you don't have any backup for that protection that replace it in case it's a failure, then as you see, it's a disaster. It can have a big fire or a blowout of a transformer that also can damage the nearby, or somebody is even standing there can also get killed. Sometimes we need to, although speed is very important, but to achieve sometimes عندنا تناقض، يعني هل متطلبات فيها ايش يصير تناقض. I want to reduce the speed، يعني make it very fast on the expense of sometimes selectivity. I lose selectivity. Okay, so or on expense of reliability. So we want to maximize this so that you achieve all of those. Sometimes we, in order to achieve selectivity, we need to make a small delay so that we achieve the selectivity. Inshallah, in the coordination chapter I think 4, will take this. Why you want sometimes, although speed is very important, but you want to delay it in purpose. Okay. What are the inputs to a relay? Already I mentioned these to you. In addition to the GPS, sometimes is used as input to a relay to synchronize the measurements between two ends of a transmission line, for example. Protection zones. Protection zones are normally each major equipments are protected by one relay, okay, one protection system, I would say. For example, a motor, big motor will be one protection functions dedicated for it. And for a transformer, for example, I have one dedicated protection for it. And for generator, normally, because generators and transformer are as one unit, consider as one unit, and if a fault's here, you need also to disconnect the generator from the system. Or if the fault in the generator, you need to disconnect also the transformer by disconnect this breaker. So we consider the generator and its transformer as one unit. So it's one zone of protections. Because fault in either of these would lead to disconnect both of them from the system. So we consider this is as one zone for generator and its transformer. Bus bars have their own zones of protection. So faults in the bus bar will be detected by a protection system dedicated for detecting faults in the bus bar. Transmission lines or cables have a zone detected for protection functions dedicated for the transmission line faults. And and so forth. I have a transformer, also I have protection function for it. So, and these zones are overlapped. نلاحظ ان المنطقة هاي is overlapped. So why do we need to overlap? الهدف اني we don't leave any spot in the system that will not be detected. So yeah, and how do you achieve this overlap? By placing the current transformer locations at the proper location. Now for the protection, if I want to expose in this bus bar, I'll use this CT and this CT here, and this will go to the relay, differential relay 87B, which compares the current leaving the bus bar and current entering the bus bar. Okay, if the currents are different, means we have a false in the bus bar. And the differential relay of bus bar protection will give a command to all breakers that are linked to this bus bar to clear the fault in the bus bar. While for for transmission line, we will take the CTs here and the CT here, and this will go to protection functions. So sometimes we have protection functions here, but looks for fault in this direction, and we have a protection function here that looks for faults in this direction. And this is like an 80, let's say 27, the distance relay. 21 relay, distance relay. It requires a voltage, and it requires a voltage from, it requires VT and a CT. So this relay is 21 relay is used to protect the transformer. Detects any faults here or here, but mainly is detects faults in the transmission line. But also can work as a backup, inshallah, of fault outside this line. Similarly, I have also a distance relay here, which requires a voltage and a current, and try to find faults in these directions. And sometimes these two relays, they communicate with each other also, as I showed you in the previous lecture. So these two relay are as part of the protection scheme or system dedicated to protect this line. Okay, so this is its zone of protection. And similarly, other I can give you as many examples. And this is how we achieve the overlap. Sometimes we have two CT, sometimes we have one CT with two secondary, feeder. Sometimes we have one CT, but we have two secondaries in the CT. So we can use them one for each side to create the overlap. Any questions so far? Okay. So this is an example also of a system with the overlapping of zones. Here just shows the differential protection to detect a fault in the generator winding I have a CT here and a CT here that feeds. Okay, so if any fault between this point and this point, consider faults in the generators, and this defines the zone of the generator differential relay. Okay, the zone of the relay from this CT to that CT. So any fault here or beyond the CT will not be detected by this differential relay. There are other protection functions that can detect also faults, maybe here, okay? Similarly, for a bus bar protection, this bus bar, then now we have two bus bars. We have this and this sections, and they have, this is, I call it a bus tie breaker, which split the bus bar into two sections. Now each bus section has a differential, it defines a zone. Okay, now how do you protect this section? We use, how do you detect the zero faults in this sections? We use differential relay also. So we have a CT here, see where the CT is the relay that detects faults in this section. A CT here and a CT here, this CT, this CT. So all currents that enters and leave this bus bar. So so I have a current entering, could be from here, leaving from here, and also can either enter or leave from here. Depends on the current from this bus coming or from leaving to that bus. So this current could be in either direction. So in this case, with these, if you link all of this together in parallel, okay, we'll come to this. This is now all these current measured from the 1, 2, 3, 4 CTs will go to the bus bar section 1 differential protection. So this defines now, this area defines the zone of the protection for this bus bar differential protection, bus bar 1, but will not detect any faults here because this fault is not within the zone of the bus bar 1 protection. Okay, so when any faults here, okay, faults, it will be detected by this bus bar protection, and this bus bar protection relay will give a command to these to trip all these breaker in, okay, including this, so that this section, this fault is isolated and the remaining system will continue. Let's take an example to illustrate if you understand these things or not. In this system, I have a transmission line that has a transmission line between A, B, and between, I'm assuming I have a source here from this end. This is a radial. There is no source, this is just a load here. Okay. Now, which relays? Now, R means the relay, protection relay. B means a breaker. Okay. And I define the zones. So always zones start before the breaker because CT locations will be here and CT locations will be here, dedicated for protection system responsible for detecting faults within this line between A and B. Now, which relays and breakers should operate for fault at F1 to clear this fault?
1 and 5.
5 and 1.
Okay, so relay, this one will see, oh, this fault is in my zone of protection. So it should, if it is reliable and selective and sensitive, it will detect this fault. And similarly, the R1 will detect this fault in this zone. So both R1 and R2 will detect this fault, okay? Because the fault is within their zone of protection, within their area, territory, responsible territory. And as a result, they will give a command to the circuit breakers B1 and B5 to operate. So B1 and B5 also, they will operate. Once breaker 1 and 5 operates, this fault will be clear because there will be no current from this end. I'm assuming I have a source here, I have a source here, because opening this breaker is not sufficient. I will disconnect faults coming from this source, but there will still a fault current feeding this from these two ends if I don't disconnect this. Okay, Shabab? So with this, I will disconnect any other faults coming from this end by opening breaker 1. So in this case, can we consider this selective? Yes, because we disconnect only the faulty equipment, which is the transmission line. This is so selective. Hope, is it fast? I don't know, and I didn't give you any timing. Okay. Is this considered reliable action? Yes, it is reliable action. Then these two relays supposed to operate and operate it correctly. Okay. Now, I cannot judge based on sensitivity, and I don't have what was the minimum current that they supposed to detect that there is a fault, and what was, and we to detect sensitivity to evaluate the sensitivity, we have to do a testing. Okay, what is the minimum current at which they detect there is a fault, or when it's with the impedance at which they detect there is a fault, and okay, and we compare the actual measurements with the settings. Relays and breaker that operated for which relays and breakers looked for fault F2?
R1 وR5 وR6 وR7.
No, F2 is lying where in the overlap، يعني صار في المنطقة المشتركة بين البusbar zone والline protection zone. So this relay will think that this لأن الCT هني of this relay, so it will detect this faults within the yellow zone, within the fault within this zone. Okay, and also will inform this guy, oh, this fault is within our zone protection, so you should also operate. So it will also give a command R5 to open breaker 5. So in this case, also R1, R2, breaker 1, breaker 5. So not R2, R5. I'll say R2 is R5 here. This R5, nobody corrected me. So R1, R5, B1, B5. So these will clear faults within this zone. لأن الفولت within this zone، فعشان كذي إن this relay will detect this faults and clear F2. But also this relay, which is this is the bus bar, bus B differential protection. So هذا هدفه انه detects any fault within this bus bar لأنه bus bar zone. فالfault within also the zone. So what this relay does, any fault within this zone will give a command to this breaker, to this breaker, to this breaker, and to that breaker too. So in this case, I have also R. I cannot complete it here. So in addition, I have R1, 2, and breaker 6, breaker 7, and breaker 8. So all of this is related to condition 3. What about fault 3, Shaba? How do you achieve selectivity? معاي؟
دكتور معك.
Okay. شلون؟ Which one responsible now يعني to clear this fault?
الباسبار ريلي.
bus bar relay B لأنه الfault now is not within his zone, not within this zone. Okay, it's only within the blue area zone. Okay, لأن city's location is here for this relay. شلون يعرف إن وين حدود الريلي؟ هي مواقع الCTs that feeds currents to R12. So مواقع الCT هني. Okay. So based on this relay will declare faults within bus bar and will give commands to kill breakers متصلين بالبس bar. Okay, so in this case R12 relay and B1 و B6 7 B6 و B7 and B8. Okay. What about fault at 4?
6 and 11.
relay 11 يكون
6 و 11. ليش تبغين 6 و 11؟
لأن الريجن الأصفر صاير داخل الريجن الأزرق.
اوكي، هذا ايش معناته؟ يعني هذا احنا نقول ان اوكي relay 6 اوكي can detect faults up to this point. All right, can detect faults up to this point. يعني any faults here or here or here or here can be detected by this. But it's not necessary it should operate إذا في overlap بين هاي الزون اللي هي 6 مع another protection لأن هاي totally inside لا. فمعناتها إن we will not achieve selectivity إذا الفولت هني وأقدر أعزله عن طريق breaker just opening breaker number 11 وأروح أعزل بعد breaker number 6. أوكي، طبعا هني شنو بخسر؟ إذا عندي لودز هني أنا بفقد اللودز يعني اللي suppose I have load here and I have a load here. Okay. هني I will disconnect this line unnecessarily. عشان كذي هني يصير إيش؟ إن relay 6 is coordinated with relay 11 such that this is delayed to provide a chance for 11 to act first when there's an overlap. Okay, يعني protection function, if two protection function are overlapping, one protection function zone is fully overlapped with another. It means this relay can provide backup for failures of R11 to detect faults within this area. إذا عشان لو قلنا in both 11 and 6 will operate to clear this, that makes the system not selective. Okay, the protection function not selective. يعني عشان يكون selective for 4F4 I have to this has to be detected by this relay and should operate breaker 11. So this case should be R11 and breaker 11. Now, will R6 see this fault? Yeah, it will see it. But it will not act immediately. It will wait for 11 to act first. And if 11 failed to take action, then R6 will trip its breaker. So this is intentionally time delayed to provide chance for AR11 to act first. فنقول احنا هني هنا نسميه R11 is the primary protection for detecting and isolation of faults within its zone. But we have backup for R6 for R11 failures, which is now R6 acts as a remote backup for R11. So this is where the conditions 5. If P1 مفهوم الحين هاي الكيس شباب؟ لا ايه if R11 now failed يعني الفولت is 4 and R11 did not detect this fault هنسميه loss of dependability. ليش؟ لأن الفولت within R11 zone و R11 اللي هو الريلي ما اكتشف هالفولتس فنسميه هاي loss of dependability أدت إلى loss of reliability of the protection of protecting line CG. فإذا what happens لو ما عندنا باك اب معناتها الفولت بيظل موجود. اوكي and we have to clear this fault حتى لو كان على حساب نفصل شيء اضافي ما في فولتس. فالحاله هني عشان نحقق selectivity. اوكي now which relay now this fails for fault 4 now R6 would operate okay and to trip breaker 6. So with this case this is called remote backup protection. Okay now why is remote؟ لأن relay 6 is not at the same substation. This is far away from this relay. They are each relays are at far distance from each other at different locations and there is no communication between them. This doesn't know if this has failed, only knows by time delay. يعني it detects a fault and fault persisted for long duration, this knows that this means that relay did not act it. Okay. If B1 failed, low breaker 1 failed, والفولت F1 what would happen؟ يعني الفولت F1 الريلي هذا شاف الفولت عطى امر للبريكر 1 الريلي فال شاف هالفولت عطى امر لبريكر 6 بس البريكر that has failed. فساعات احنا المشكله مو في الريلي المشكله تكون في البريكر اللي اصلا ما استجاب لامر الريلي لان it's a mechanical device so it did not operate it. فشنو الحل؟
فبيشتغل R6 بيعطي B6 B7 بيفصلها كامل يعني.
ايوه هذا نسميه احنا باك اب يعني نحتاج ل باك اب بروتكشنز that substitute a breaker failure والبروتكشن هني لازم يفصل لان البريكر هاي ما فصل معناته لازم نقطع الكرنت اللي جايين من هالسورسز اوكي فلازم نقطع شنو بريكر 7 وبريكر 8 صح and يعني in this case عادة this is not necessary بس okay I will open it also لأن طالما أنا ما عندي supply هني but generally for breaker failures كل بريكر المتصلين هالبس بار ينفصلون in this case I will trip breaker for P1 failure then breaker 6 breaker 7 breaker 8 and who will give these actions من الريلي مسؤول عن هالاكشن
R12
R12 لا R12 ما بيكتشف هالحالة
R6 اقول
R6 ما بيكتشف هالحالة
R5
R6 مسؤول عن فولتس هني مو مسؤول ان هالبريكر يعني ما اشتغل او لا في ريلي طبعا هذا الريلي في عندنا فانكشن نسميه بريكر فيلير لو تلاحظون في في هني let me check breaker failure هذا functions I don't know if you can see it breaker failure protections means a relay give a command to this breaker failed okay. So what will it does يعني شنو البريكر failure اساسا how do you know relay ان البريكر does not طبعا الريلي هاي لما يعطي كوماند يبدا العد في عندنا فانكشن ثاني داخل الريلي او قد ساعات بريكر فيلر يكون another ريلي سابقا بس الحين هذا كفانكشن الريلي لما يعطي امر الى البريكر يبدا العد عندي تايمرز هنا اوكي التايمر هاي يبدأ العد بعد ما يعطي للريلي أمر للبريكر إنه يفصل تايمر طبعا التايمر ده قاعد يقارن شنو أولا يبدأ العد من لحظة الأمر إصدار الأمر من R1 ويقارن لا زال كرنت موجود فولت يعني السيتي اللي هو هذا لا زال يمر فيه كرنت والأمر صدر من R1 to trap يبدأ التايمر يشتغل يفترض ان البريكر معروف ان المانيفاكتشر قال ان هاي البريكر يفصل خلال 3 سايكلز خلينا نقول 60 ملي سكندز والكرنت لا زال يمر يعني هذا صدر امر ان الفصل ولا زال كرنت موجود بعد ما انتهت ال 3 سايكلز هو ايش يعني يفهم هاي الريلي ان البريكر هاز فيلد وبالتالي يعطي هذا البريكر functions this will give a command to all these breaker to trip and this is called local protections. هذا الحالة نسميها local backup protection اللي هي breaker failure BF breaker failure protection. Any questions so far? فإذا أنواع البروتكشنز عندنا primary protections وعندنا backup protections. The primary protections هو المفروض protections that should act first to clear the faults and to represent the first line of defense. Okay, so each major equipment, it has at least one primary protections, and some equipments like very important transmission lines, it has two primary protections. Each should act fast to clear the faults, but at least we need to have one backup. In case of the primary protection failed, we need to have a backup protections. So backup is dedicated, it's always time delayed. Why? Then I will always take action by the primary to act first. The backup sometimes will, if you acted by backup, sometimes we lose more than one thing. If the breaker failure here, I have to also disconnect this line. So opening breaker at the bus bar, you will lose a lot of things. You don't want to take this action just for any faults, unless it is necessary to clear that faults. So it's normally time delayed and can be either local backup protection or remote backup protection, as I explained to you in the two examples above. This is another examples on I could have two primary protections at R1 and R2. Even here, 5, I have 5.1 and 5.2. Suppose this is R1 and R11 and R12. So we have two relays at each end, and each relays acts as a primary protection. But each of these relays detects faults using different principle. Maybe this one using 21 function, this one using the 87 function, so that you assure that any fault within this zone will be detected. So duplicating primary protection will give you two things: fast action to clear the faults, and it makes the system more reliable, dependable, in this case. I already explained the, this is the local backup protection, which is breaker failure. In this case, I'm showing R3 as a relay that if a faults in F1 and R1 and R2 are duplicate protections as a primary, so R3 here, and if both of them fail to detect this fault, both of them found this fault, but I have breaker failure, then R3 as a function, as a relay, acts as a breaker failure relay. So this relay will give information that they have already sent a command to this breaker, and this relay will not trip this breaker unless the time is elapsed. بعد ما يعطي الأمر هاي، هذا بينتظر الوقت المطلوب اللي اللي على أساسه أنه هذا البريكر بيفصل فيه، وهذا الوقت انتهى ولا زال كرنت موجود، فالريلي هذا يفصل. طبعا سابقا كان هذا الريلي مستقل، حاليا هذا ما يحتاج إلى ريلي إضافي. It's already a function حاليا. I don't know a relay for backup as a breaker failure. It is already a function inside the relay, okay, that detects this situation, okay? But it used to be a separate relay before in old technology. So this is also same, we are talking about local backup and remote backup. This is already, I explained already. For directional, do you have 1 minute more, شباب, or you خلاص?
It's fine.
Okay. So we have also protection that we call it directional protections, okay? And we have one chapter on this. Don't worry if you did not understand already what I have mentioned. We'll repeat these things again, okay? Directional relays are relays that only works when they detect force only in one direction. يعني why do we need directional relays in situation when we have mesh network يعني or parallel lines, or when we have systems that have multi sources, more than one source in the system, but these sources not at the same location, at different locations. So it's not means I have a source here like this means no. That means I have a source sometimes, a grid network of I don't know if I have it here. No. Sometimes let's say bus bar here. Let's give two substations. I have a load here and a generation here. Okay, now this is a loop system or a ring system, and has also multi-source. Okay, so in these situations, you cannot protect this line using non-directional relays. So you should have directional relays. Now let's see this situation. A fault is very close to breaker 2. And this systems, I have a relay here, non-directional, a relay also at 1. This fault, for this fault very close to 2, the current will flow here to this fault will be equal to the fault coming this way. So this I1 and I2 will be same. And because of this, if you set this relay pickup setting and this pickup setting are same, it will lead that, and they are non-directional. Suppose sometimes we achieve selectivity by timing. يعني نخلي هذا عند 0.1 second يشتغل وهذا عند 0.5 فرضا seconds. هذا بعد 0.5 seconds يشتغل، هذا عند 0.1 seconds يشتغل. فعند whenever this sees a fault, لأن it can see a fault whether current in this direction or current in this direction, it will detect a fault if it is non-directional relays. So because it's a fault now in this direction, so and it operates within 0.1 seconds, and this also because this is non-directional, it sees a force in this or in this direction. Because it sees this force, also it will operate at 0.1 second. So both the 2 and 4 will operate in this situation, and you have lost the selectivity. Why? A fault in this line 1, I'm also disconnecting a breaker for line 2. So I lost this load. So to achieve selectivity, only line 1 should be disconnected by breaker 1 and breaker 2, and breaker 4 should not operate. And to achieve this, we should use a directional relay. So this هسام هاي معناته ان الريلي هاي بيشتغل فقط إذا الفولت في هالدايركشن. فالحالة هاي الكرنت will go from this relay so in this direction, and this current will go from this side so in this direction. What does that mean? Fault in this direction, but the tripping action in this. So because relay 4, a tripping action is opposite to the current direction, 4 will not operate. This will restrain. And it will refrain from operation because the fault current is opposite to the trip direction and will not operate, although its settings at 0.1 second. And this settings at 0.5 seconds. But because 2 is trip direction same as fault direction, so this 2 will operate. So the sequence of operation in this case, 2 will operate at 0.1 seconds. Once 2 operated at 0.1 seconds, fault will be cleared. So there will be no fault coming from this side. So this fault will be removed. But this fault still will flow. So after 0.5 seconds, this one will operate and will clear a fault here. So there will be no fault anymore once 1 and 2 are operated. So this can be achieved by, or خلينا نقول loss of selectivity can be achieved by having directional relays. Now, how do we achieve directionality? What do we use to make the relay only acts in one direction and doesn't act when the fault in the other direction? We have one chapter covering this, inshallah. And I will leave this exercise for you to work on it. Inshallah, next lecture I will start see what's your answers for this and start with a new chapter. Thank you for your patience, and I'll stop recording.